This example's been made somewhat easy because the actual probability tree is given. But let's just have a bit of a talk about the construction of that probability tree. This situation involves Mrs. Goff driving to work, passes through 3 sets of traffic lights. So first set, second set, third set of traffic lights. The probability of a red signal, including amber, on each light is 0.3. Now, we would have to be given that information. There's no way we're expected to know that. So this is a given piece of information. So we're saying the light is either red or, I guess, not red. In the tree probability tree, they've chosen to call it green. I guess that's correct because red is including amber. So has probability 0.3. If we didn't know that, we certainly wouldn't know the probability of green. But knowing that it's 0.3, we're expected to be able to come up with the 0.7. How? Because we know, from what I've been saying, these 2 probabilities must add to give 1. So, if the first set of lights was red, there is no reason why the second set of lights couldn't be red, or it could be green. And the probability is not going to change. It's been stated that the probability of a red signal anywhere on each light is 0.3. So red is always 0.3. So the first light could be red, the second set of lights red, and the third set of lights red. To get the probability that they're all red, we multiply across the branch. Multiply across the branch. Now that's something that needs to go in your key points and summary for this exercise. That to find the probability, you multiply across the branches. So A is asking for all green lights. All green. So that's down the bottom here. So the probability that we would get green, followed by green, followed by green is 0.7. You can see I am multiplying by each probability on each branch. And I'll leave that for you to do. The probability of 2 green. Now, this is going to involve a couple of branches. So which branch do we want? 2 green. Well, the top branch isn't an option. This second branch isn't an option. And really we should do what I've always said is the most useful thing you can get from your trees, and that is to list the actual results. So we've got red, 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 green, red, green, red, and red, green, green. Then we've got a green, red, red, a green, red, green. We've got a green, green, red, and a green, green, green. 1, 2, 3, 4, 5, 6, 7, 8 items in our total sample space. But we're not so interested in the 8 anymore because we've got the probabilities on each branch. So with B, how many of these branches do we actually want? Which ones do we want? As long as it's got 2 green. So we want this one. Oh, sorry, no we don't. We want this one. We want those 2 green, those 2 green, and it's just saying 2 green lights. So the last one was 3 green. What we have to do then is to add the probabilities from each one of those 3. So our sum will look a little bit like the probability of the red, green, green, add the probability of the green, red, green, add the probability of the green, green, red. Sorry about that. what would the probability of a red, green, green? A red is 0.3, and then a green is 0.7, and followed by another green is 0.7. You can probably see already that these are all going to be the same little calculations. Our green first, which was the 0.7, followed by a red, green first, followed by a red, which is 0.3, and followed by a green, which is 0.7, which is exactly the same as this calculation. Third branch to add on is the red, 0.7, sorry, the green, we're going green. Green is 0.7 times second green, 0.7 times a red. So again, that's 3 times what that calculation. They're all the same, 0.3 times 0.7 times 0.7. And I'll leave you to do that calculation just using your calculator. C, it's a really common sort of question. At least one green. The probability of at least anything is 1 minus the probability of none. Oh, sorry. So the probability at least 1 is 1 minus the probability of none, and please add this to your right here, your summary and key points. The probability of no green at all, is the top branch where they're all red. The probability of no green ones would be 0.3 times 0.3, whoops, too many zeros there, times 0.3. And again, I'll leave you to do that calculation because that's just using your calculator. Please make sure you add this statement here to your summary and key points. It's a very common question and it can save you a lot of time if you know that. You should be right to do the you-do for this last exercise.